This is a lesson on finding a factoring strategy, which is intended for Math 03 students or even Math 04 students who are looking to review their factoring strategies. This is intended to be used after you have learned each of the methods for factoring, and you're presented with a page of factoring problems that don't say specifically factor this difference of squares or factor this using the AC method. This is how you decide, based on what you already know, how you decide what method to use for factoring. So what we start out with is asking ourselves this list of questions. So I've got a factoring problem in front of me. The first question I'm going to ask, and this is on every factoring problem you're faced with, do I have a common factor? Is there a common factor to all of the terms of the polynomial, whatever size it is? And if there is, factor that out. That's the greatest common factor, or the GCF. If you have one, factor it out. Once you have factored it out, look at what you have remaining after you factor that out and count the number of terms. That's what we need to know next. How many terms does a polynomial have? If it has two terms, you're looking for a difference of two perfect squares. There is also factoring for a difference or a sum of perfect cubes, but that's not going to be covered on this video. I'll do another video on that, so look for that. So if it has two terms, we're looking for a difference of two perfect squares. If it has three terms, first you're checking to see if it's a perfect square trinomial. If you memorize the pattern for the perfect square trinomial, then you just follow the pattern and factor it. If you did not memorize the pattern, and I'm sure many of you have not, then you can still factor that using the T-chart or AC method. So we've gone beyond the is it a perfect square trinomial. If it was, you used the pattern. If you're not sure, then we're going to use either the T-chart method without grouping if it's a three-term polynomial and does not have a leading coefficient, or the leading coefficient is 1. We're going to use the T-chart or AC method with grouping if the leading coefficient is a number other than 1. So again, you're either, if it had no leading coefficient or a leading coefficient of 1, you use the T-chart without grouping method, the simpler one, and if it has a leading coefficient other than 1, you use the T-chart with grouping method, also known as the AC method. Okay. If it has four terms, then you try to factor by grouping. Once you've done whichever of those was appropriate, the two-term, the three-term, or the four-term method, then you want to check your answer and say, did I leave any factors that could still be factored? In other words, if you had a difference of two perfect squares and you could have factored that again because after you factored it you still had a difference of two perfect squares, go back and take care of that. If you recognize that you still have a GCF in one of your factors, go ahead and factor that out. Once you think you've completely factored it, then you want to check it. And you check factoring by multiplying. So in almost all of these methods, except for just finding a GCF, we get binomial factors. And when you have binomial factors, you of course FOIL them back. The only thing that multiplying back will not catch is if you actually didn't finish factoring it. Because if you left a GCF in there, when you multiply it back, you're still going to get the right thing. So it won't check for that, but it will check to see if you factored everything else correctly. Okay, now we're going to look at these two factoring problems and follow the factoring strategy to see if we can't get them factored. So on number 1, which is 2m to the 4th minus 16, remember the first question you ask yourself on every factoring problem is, do I have a GCF? So I'm looking at both the first and the second terms, and I have a 2 in the first term, and 2 is also a factor of 16. So 2 is my GCF. Now I'm going to divide or factor that out. When I divide 2 by 2, I get 1, which of course we don't write in front of a variable. It's meant to be understood. Bring down my sign. I keep the sign because I didn't factor out a negative, and now I say 16 divided by 2 is 8, and that's what goes there. So now I have factored a GCF of 2 out of 2m to the 4th minus 16. I'm left with m to the 4th minus 8 in my parentheses. So remember, the next step is count your terms. I have two terms here, and if I have two terms, I'm looking to see if it is a difference of two perfect squares. I'm also checking for a difference or sum of cubes. Check that on another video. So I'm checking for a difference of two perfect squares. Well, m to the 4th is a perfect square because 4 is an even exponent. All even numbered exponents make for perfect square terms. Odd number exponents are not perfect squares. 8, however, is not a perfect square. When I try to take the square root of 8, I get a decimal number, not a whole number, so 8 is not a perfect square. Since it's not a perfect square, I have finished factoring that problem. And I'm not going to check them here, but remember, if you want to make sure you're right, multiply back to check your work. Okay, on number 2, I have 18x cubed z plus 24x squared yz plus 8x y squared z. So the first thing I'm going to do is compare the numbers. So I'm looking at 18 and 24 and 8 and looking for the largest number that divides into all three of those. Well, I'm looking at the 18 first. I have a 2 and 2 3s as my factors. It's 2 times 3 times 3. So I'm going to look and see if 24 and 8 have any of those factors. Well, 24 has a 2 and it has a 3. So far it looks like I could factor out a 2 and a 3. When I look at 8, 8 has a 2, but it doesn't have a 3, so that means 3 is not a common factor to all three terms. So the only thing that is a 2, and I'll factor out the common 2. Now I'm looking at the x terms next. I'm taking them one by one. I have an x cubed, I have an x squared, and I have an x. When you're looking at variables and you're trying to find the biggest one in common to all three, you're taking the smallest of the exponents, which means x is what I have in common. Now I'm looking at z, and in this term I have a z and a z and a z in the third term, all raised to the first power, so z is in common. So I believe I have factored everything out. So I'm going to divide now. Factoring out is the same thing as dividing out. I have 18 divided by 2 is 9. X cubed divided by x, remember you subtract your exponents. 3 minus 1 is 2. That leaves me x squared. And z divided by c cancels out. That leaves me a 1. I don't write a 1 because I don't need it as a placeholder. Plus, bring down my sign. The same sign because I did not factor out a negative, and I say 24 divided by 2 is 12. X squared divided by x, again subtract those exponents, that leaves me x to the first power, and now I have a y here, and I didn't have a y, I didn't factor one out. The reason I didn't factor one out is because there was no y in this first term of this polynomial. So y divided by no y there is sort of like y divided by 1, which is y. Again, z divided by z cancels, and I bring down my plus sign. 8 divided by 2 is 4. X divided by x here cancels. Y squared divided by no y. Again, that leaves me y squared, and z divided by z cancels. So I believe I have factored everything out. So now I am counting the number of terms I have, and I'm checking to see if that's factorable. I have a 3-term polynomial. So the first thing I want to check for on a 3-term polynomial is it a perfect square trinomial? And so we're going to check for that pattern. The first term, 9x squared, is a perfect square. Its square root is 3x. The last term is a perfect square. Its square root is 2y. So I multiply those two roots. 3x times 2y is 6xy. Multiply that by 2 and I get 12xy. So this is a perfect square trinomial. The pattern for a perfect square trinomial is take the root of the first term, that's 3x, the sign from the middle term, that's plus, the root of the last term, that's 2y, and square it. Bring down the GCF you factored out to begin with, and there you go. That hopefully is the final factored form, but remember you want to check if what's in the parentheses can still be factored further. I'd be looking for a difference of squares. It has a plus sign and neither term is a perfect square, so that means I have factored it fully, and that's the first two problems. Come to another video and I'll factor some more of these for you using the factoring strategies. So look for video 2 for more factoring practice.